Yeah, so I went to Home Depot and Harbor Freight today. Yeah, I hate going those places. Anyway, I needed to pick up a filter for an old shop vac, and amongst other things, namely a drain for the mill table, and a 5-gallon bucket, and a couple of pumps, and some polishing utensils. Alright, well, I will happen to say that the pumps were more than what I was expecting them to be. And one of them I may not even be able to use because of the aforementioned issues. So, yeah. Mr. Toad. Is that a toad? Yeah, we got Toad in here. See him? Anyway. Gotta love Florida. So anyway, I got the pumps. 50 PSI, 300 gallons per hour, self-priming. It is 12 volts though. I mean, I don't truly have a big issue with that because, well, the 120 volt ones were pretty spendy. So anyway, I went to Home Depot, and to get the right filter for the shop vac, it would have required an over filter. It's a rigid. It's not even a shop vac. It's a rigid, and they didn't have rigids. But I could have got the over filter to go over it, and then I would have still needed this foam guy here. But anyway, when I was looking in the shop vac department, I saw this guy right here. It's a shop vac that goes on a bucket. And just for reference, let me kind of go ahead and give you an idea of what I was planning on doing with the shop vac to begin with. So the coolant and stuff will be draining in through this hole right here, and it will be draining into a shop vac down below, with the pump then taking the fluid out from the shop vac and putting it back up to the, whatever I get set up for coolant nozzles. Alright. Because I'm not having like 4 or 5 drains and all this stuff, and everybody that's run any type of even large industrial machines, especially larger industrial machines, where you're generating just tons of chips, and I'd like to be generating just tons of chips. The screens that keep the actual chips from going back into your that getting sucked through the pump and getting into the filter and clogging up your coolant tank, they'll like just get jammed up right quick. And it almost doesn't matter if you're running, a Haas with augers or whatever. It doesn't matter. The issue is that the screens get covered up with fines, and then gravity can't pull the fluid down fast enough, and your tank starts sucking air. Your pump starts sucking air. Well, in this case, it might be possible for the fluid to actually then start dumping onto the floor, and we really don't want that. Plus, I want to make sure that there's constant coolant. If my pumps are sucking air, then I'm not getting coolant on my tool, and we have issues. I'm not really a huge fan of coolant on high worked carbide bits. I believe that as the cutter is coming out of the cut, it's extremely hot, it doesn't have actual coolant on it at that point in time at that edge, and as soon as it comes out of that cut into the coolant, it stress shocks the cutter and starts making micro fractures in it. So I truly believe the coolant is more of a chip flush, not even necessarily a coolant. So anyway, so to keep the chip flush going, the idea was to have a separate shop vac next to the mill, and run the shop vac into the top of the 5-gallon bucket, so that it would create a vacuum. Well, duh, because it's a vacuum. So it would create a vacuum in the actual 5-gallon bucket to pull that fluid out. And the vacuum should be not nearly as strong as what the actual pump is pulling. It's a high volume vacuum versus a low pressure vacuum. So that way that I'm always getting that forced suck of coolant out of the machine. So anyway, I'm at Lowe's, I guess is what it was, not Harbor or not Home Depot. Anyway, and I see this Bucket Max, and I think perfect, and the side locks are, beautiful as far as I could tell. When I actually get a little closer to being set up, I'll do another video. So that's that. So that way, that just goes right on the top of the bucket. The coolant goes in there. I'll have a hose popped out the top, sealed up with a grommet or something, and that's that. So my next dilemma here is that, I did have a drain, and I wasn't really too pleased with the way it was going to be. It has the other drain actually has a pop-up lever, and all of these drains, except for a bar sink drain, and I thought I had one, or I did have one, but we're talking years ago now. But I acquire parts for these projects, and then I lose them, and then I need them again, so I have to go out and buy them. But this is cheap. It was like $5.99. I can deal with that. So this is getting set in here. Yeah, it does go in there too, I swear. I swear it does. Give it a good tug. Ah, there we go. That's close enough to being flush, and I'll probably silicone that in, actually. But I do have a rubber seal on there. I found a perfect rubber washer. So anyway, that's my coolant drain, and it will go from there to I got an extension tube right here, right there, and then I'll probably print an adapter to go from this tubing here, which I will either hose clamp or something. Maybe this might even just go straight onto here, and I might even have an extra extension left over. I know this fits on there like really snug. I mean, like really snug. So that may just be a hose clamp and an adapter that goes right into that Bucket Max. And I'll probably end up putting a trap in this, even though, I mean, it's not really necessary. It's not like I'm gonna have gators crawling up out of my coolant tank, but I will anyway, just because of the way everything is sitting, and I'm not 100% certain where I'm gonna have the bucket even sitting yet. So that's the first stage of the coolant setup, and I'll be using the higher volume, higher pressure, or higher volume coolant pump for that. I did not find a suitable pickup screen at a reasonable enough price, so I will have to decide what I'm going to do with that, and I'll probably end up doing some type of trap setup. And what I mean by that is it'll be almost a bucket inside of that bucket that the coolant can get into, That way I'm not pulling chips off the bottom of the tank or anything like that. And obviously that's not a submersible pump, so that's not really a big concern. The second stage of the coolant, chip flush setup will be to actually use air lines that I don't even have plumbed into the shop yet. But to use air lines, and another piece that I know I have had at one point in time, which is it's a solvent pickup for cleaning with an air blow-off tool. It basically screws onto the end of the air blow-off tool, and it uses a Venturi effect to pull liquid up through a short hose or a small hose. And so I'll have a couple of valves. I'd like to use solenoid valves. The only ones I think I have right now are for washing machine type solenoid valves, and I would actually use those too. It's a possibility and a consideration. But to use solenoid valves for on and off of that air going to that air blower. And then the next stage of this whole coolant process type of deal is to take one of these smaller, cheaper stepper motors, less expensive stepper motors, something like this here, and actually get that set up in a small box. Yeah, that'd be fine. This guy right here, little NEMA 17. Get that guy set up in a small box on the side of the spindle, and actually do a remote coolant adjustment. And I know I'll have to do some type of silly macro or something like that. But different coolant levels when I actually change tools. And I could probably, and this is probably what it'll end up being, is a macro that actually adjusts coolant height based on work height versus tool offset height, maybe. So anyway, that's the goal anyway. Pretty ambitious goal too, I think, but very doable, very doable. So the motor will be sitting, here or here, or heck, maybe we'll get, here or here, or something crazy. Maybe we'll even get crazy and we'll do two of them, one on each side. Heck, one on the front too. No, we'll do one for air and one for air and one for liquid. That's what we'll do. We got enough steppers, might as well. One for air and one for liquid, and that'll be that. And like I said, the air will also have that Venturi pickup, liquid pickup, to actually go ahead and grab a small amount of coolant. So it's almost like a cool mist type setup. That if any of you are familiar with machines and machining, you'll be familiar with the cool mist setups. Alright, one more thing here real quick before I get out of here, and this has to do with my HID lighting setup that I'll be putting together. This is just a piece of U-channel, and I think at some point in time in the near future it is going to be mounted somewhere around right here, maybe, or once this whole assembly is actually done, maybe right around here, basically directly diagonal from the corners. And the reason I got the polishing equipment is because this has to be polished to like a near mirror finish. Yay, fun. And then I need to make end caps for it. One of them is just solid and one of them for the light bulb, and that's why I picked up the piece of Lexan to just go over the top of it. And I have not decided if I'm going to slide it and have the Lexan slide in, or if I'm gonna be you know, can't even say lazy, because it'd almost be easier to clamp that sucker in and slide it on both sides and have something slide in, or if I'm gonna drill and tap in a couple of spots on each side and put in an L for holding it. Putting in the L to hold it might be a little more coolant proof. I could also go ahead and take and bend that Lexan. Put a little bit of heat on it in the right spots and actually bend it and get a nice form and wrap it around there and up and over, or up and in. Might actually be the better situation to actually take it and wrap it in, but then that'll take out some of my reflectivity. We'll see. Either way, it won't be too bad. It's not like there's going to be a ton of coolant splashing around in there. Yeah. Okay. All right. Have a good night. Thanks for watching. Like, share, enjoy. See ya.